Okay, um, I'm really excited to be here today to share a line and guide you guys as you guys navigate through the path to become an associate cloud engineer. And today we are going to have one of the most interesting topics. By the way, welcome everyone. My name is Mofiro Jean. Most of you might know me in the community as the Angular Man. And today we will be shifting our gears from, talking about front end stuff, right, to the world of infrastructure. We are going to start our journey with Google Kubernetes Engine, which is commonly abbreviated as the GKE. Like for many, moving from the traditional servers to Kubernetes, it might feel like a giant leap, but today we are going to show you how the Google Kubernetes Engine will actually bridge the gap and then turn infrastructure into a scalable service. Without wasting further time, we are just going to move right into details. So, when we talk about, before, we talk about engines, we have to talk about the fuel, you know, what actually powers the engine, and those are containers, right? You can think of a container as a suitcase of your code. That's for your code. It is an isolated space that packages, you know, all your applications along with every single dependency. I'm sure most of you are familiar with Docker. Can I have a deeper understanding of what this means? Like it packages all your code and all the dependencies that it needs, and then um, I'll ask you a question like, why is this better? Like, why is it better? You know, why are containers even better than virtual machines if you want to look at them in that sense? So the first thing I would like to talk about is because it is lightweight and it shares, the host operating system kernel instead of carrying the whole operating system. That's one major thing because containers are very lightweight. Also, it gives us profitability. Profitability in the sense that you build once and you can run it anywhere. It is consistent in every environment, from your laptop to the cloud. So you can build it at once on your laptop and it will run exactly the same way in the cloud. You know, no more it works on my machine excuse, those kind of things where when you are talking with a client and the client is like, it doesn't work on my machine, but you tell the client it works on mine. So this is one important thing before we dive right deep into the Google Kubernetes engine. But we have been calling Kubernetes and we just spoke about containers. And now I would just like you to understand this. So now, managing one container can be very easy, but like what happens when, you want to scale your application, to become one of the next big things, for example, like the Facebook, and many other platforms that are that high, especially when it comes to that scalability. And you will realize that you now need like thousand, instead of like a group of containers, across the globe that are going to work in line in order to ensure that the services are delivered to all the customers. That's where Kubernetes actually comes in. It is an orchestration framework, and this is something you need to take note. An orchestration framework, right? So this is one of some of the questions that usually come for your associate cloud engineering course, and I think it is very important that you have to look into this, understand why it is called an orchestration framework. Um, it handles auto scaling for you. That's adding containers with traffic spikes. When there is more traffic, more containers are added. Where there's less traffic, the containers are reduced in order to attend or to service the concentration of the traffic. Also, it handles self-healing. For example, if a container crashes, Kubernetes notices and then restarts it automatically. And um, most importantly is the fact that it is declarative. Like you can find it here, the declarative management. This is in the sense that you will tell it the desired state. For example, I want 3 copies of this app, and Kubernetes does the work and make sure, we stay true. And even if a server fails, we will still survive. So we have had like a comprehensive knowledge of what Kubernetes is. The next key thing we are going to have a look into is, the Google Kubernetes architecture. Because we have been speaking about this words, but it is very essential that we have a deeper understanding of these building blocks that make up this architecture, right? We can now, let's look under the hood for this architecture. There are actually two main parts, right? The first is the control plane, right? This is the brain. As you can see here, this is the brain. Um, that coordinates everything. It coordinates the clusters. It also includes API servers which you can talk to, and the scheduler and the controller manager. All these come to play, in order to allow us build and scale. So the next thing, the second thing are the nodes, as we can find them. These are the nodes. You have worker nodes, worker nodes, worker nodes. But when you hear of nodes, you think of like they are worker virtual machines, that do the actual heavy lifting. They do the actual heavy lifting here, right? Why the control plane ensures that we have a brain that coordinates every activity, right? So we are going to now move. But apart from like inside the notes, actually there are some key things you must understand. As you can look in the diagram, inside the notes we now have what we call pods. And in Kubernetes we don't deploy containers directly, we deploy pods. And a pod is just simply the smallest unit. It provides a network storage, it provides storage for your containers, because Google manages the brains. So because Google manages the brain, you get high availability and less headache, because Google takes care of it, right? So, lastly, under the Google Kubernetes Engine, we are just going to talk about the various kinds of operation mode that exist. As you prepare for your, as you say, cloud engineering exams, you will need to know which mode to choose. You know, in this course and on when we talk about clouds and the Google Kubernetes Engine, there's one thing we must think about. Um, you will need to know which mode to choose and when to do it. So we can have the autopilot, which is often at times by default recommended. Google manages the nodes, the scaling, and the security. All you only pay for is the pods that are actually running, right? You don't you don't keep your mind preoccupied with other things that could, you know, lay you down. One advantage for it is that it pays only for the pods you run. So you don't pay for the entire thing. You just pay only for the pods in your application that are actually working. Now it is best when you want to talk about production workloads, or reducing operational overheads. The other option, or the other one we have, or the other kind of mode we have, is the standard mode. This is for the experts who need full control over the underlying virtual machines and the specific hardware. So for most of your production workloads, the autopilot is the way to go, because it significantly reduces your operational cost. So that's one key advantage of this. One key of it, you actually pay for the provisions of the virtual machine resources used. So you can now see that based on this, you can understand which kind of operation mode you will execute when you want to work with your Google Kubernetes engine. Um, that's all we have under the Google Kubernetes engine. I believe you must have had now like a solid understanding of what the Google Kubernetes engine's architecture is all about, what containers are, and what Kubernetes is. And we will dive right into our next. Before I will talk about this, and then I will show you um, in the course material some how to go about understanding, learning, and then engaging yourself into this course in such a way that you get the best out of it in a way that you can apply it to wherever you are. So the next section here is we will talk about um the cloud run. So this is like a brief introduction to cloud run. And now I'll ask, what if you want the power of the containers, but you don't actually want to manage the clusters at all? Uh-huh. That's where the cloud run comes into play. Cloud run by definition is like a serverless platform. It runs stateless containers and abstracts like away from all the infrastructures. And one of the best parts is that it scales to zero. If nobody's using the app, bam, you pay exactly $0. And as someone who loves Angular and the fact that sometimes you have to do enterprise applications, I love this for backend APIs or SRS SSR apps, because it scales instantly from zero to thousands of instances the moment a request hits. So I would personally, for one, like this, especially when it comes to deploying my application. So the next thing we are going to look at the cloud raw resource model. Now, to master Cloud Run, you need to understand its hierarchy, right? We have the service. It is your main application, right? The top level resource. It's unique, permanent endpoint. That's our URL for application. So you have this. We have service. You have service. And then from the service, the next section is our revision. But what happens with the service is that it is kind of like the main application, and it gives us a permanent URL. Every time you deploy a new version, Cloud Run will create an immutable version of it. This is a snapshot and it will never be changed. We also have things like the job. These are just task-based executions. So a job are for tasks that can run completely and then exit, like a database migration, or maybe a schedule. You try to schedule a report. um and you can notice we already mentioned revisions as immutable snapshots, like they are created automatically for every new deployment config change, right? One other key thing we need to look into is the container life cycle. The container life cycle. Now you will ask yourself, like, how does a container live in Cloud Run? Um, and then let's say it starts when you know you a request comes in. For us, for this life cycle to be purely explained, we need to be able to highlight some of the key processes that takes place when a request hits the service, so or the server. So what happens is that if it is the first request, you might experience a cold start. While the container initializes. So you notice that that's what we experience at initialization phase. We call it the cold start because the server is just trying to initialize. Um, once it is done serving, so the next process in the container is service. We can see it's called active. Actually, we said it's active, but this the process is called serving. So the acting process, the container is actively handling income, like incoming traffic. And then after the request has been done, the container will stay for, like, it will stay idle for a moment, waiting to see if more traffic will arrive. But in case, so if the room stays quiet, what happens is that the cloud run will gradually shut down, every instance. Um, this life cycle is the secret when it comes to trying to understand the cost effectiveness of a container's life cycle in Cloud Run. One other key thing we are going to look into is traffic management and rollout. Because revisions are immutable, as we mentioned above. Um, Deployments are incredibly safe. Cloud runs allow us for traffic. You can also send 90% of the users to the stable version, and then 10% of the new users to the coronary version, um, to test a future. If something, if something goes wrong, if something goes wrong, uh, with your new code or whatsoever, you now see where we have the rollout. You know, a rollout is instantaneous. It is being executed. It's been initiated immediately, uh, and then you just shift the traffic. That's most of the traffic will now be shifted back to the previous version of the system where it wasn't experiencing any downtime. And this is very important because sometimes when designing systems we try to deploy like we want to try and deploy new features as they come in. But what we try to do is that after implementing a new feature, we test it out by allowing just a significant amount of population to interact with the new changes. And when we discover that something happens, we just move back some of the rollback, just or to roll back to some of the changes. So I believe from here you've understood traffic management and definitely also have a good and a deeper understanding of what the rollouts and what their functions are in our cloud run. And lastly, on this topic, we were going to talk about, some of the triggers and then some of the integrations as well. Finally, I'll ask this question: how do you trigger these containers? The most common way is to use HTTPS request directly to the web traffic. We can have it there, HTTP request directly to the web traffic, and then, but you can also have, as or asynchronous triggers. We call them like pop and sub messages, or event trick. Imagine a user uploads a profile picture to, our storage bucket. Event Arc, can trigger a Cloud Run container to automatically resize the image. Like some other key things we can look into is and for the security as well, we can use the serverless uh, VPC. That's VPC access, and to connect your containers now to a private database like Cloud SQL without exposing your secrets to the internet. So these are the various triggers and some of the integrations that Google had to ensure to put into our Google Kubernetes engine, right? So I believe we have really cleared much about this. I'm just going to walk you through the course. We will not really do any lab session for this. And also, in case you need to get in touch with us, if you have any questions as you proceed with this lab, please feel free to reach to us and contact our team using the following Gmail address present to you. So I'm just going to walk you through the course and give you a deeper understanding of
The
what this is all
applications that
about.
run in the
And
containers
okay,
need
yeah.
to communicate
So
over the
before I can
network,
actually get
but you don't
to,
have a
you can
network
actually
fabric
see
that lets
how
containers
the
find each
course is
other.
going on currently. I
Kubernetes
would
can
just like to move back a little bit so you can see. So, um, in this lab, you're going to focus more on getting started with the Google Kubernetes engine. You can see they say welcome. You're getting started with the course. If you're interested in Kubernetes, a software layer that sits between your applications and your hardware architectures and hardware infrastructures, you know, it's very essential that you have to go through these materials one after another and get a deeper understanding. You know, the course comes in different categories. We have lessons, we have labs, and you even have quizzes in the form of checks. And you have several labs as well when you go through the course. For example, we have this lab. The lab is 1 hour, and they will tell you about all the details and all the intricacies you need in order for you to be successful in this lab. I also hope that you have redeemed your cloud credits in such a way that you'll be able to use them, because if you haven't redeemed your cloud credits, I don't think it will be possible for you to attempt these courses without you being charged, right? So after redeeming your cloud credit, I think that was the first thing that was done for um, this journey to becoming a certified associate cloud engineer. Um, this is just one of the lab sessions where you're working with cloud build, and it is very important that you follow the instructions that are provided. And if you have redeemed your credit, it is also going to be much more advantageous to you, or else extra charges will be applied. It is also very important that you follow the instructions given so that you can be able to achieve the results that this specific lab requires of you. And so with this, I believe if you carefully follow the course materials as intended, you will have a deeper understanding, and your mind too will be shaped concerning this particular topic, which is the Kubernetes engine. For more info tips and for more questions, if you have any questions, please ensure to drop them on the comment section, and we will do our best to respond to you. We also have our WhatsApp groups where you guys are found in. If you experience or you have any issues as you are trying to attend to these courses, please ensure to drop them in the group, and we will do our best to respond to you. And if you go through this course completely, you will see that the more you proceed ahead, the better understanding you have. And if you look at how I structured my slides, I started by giving you like a simple understanding of what the Google Kubernetes engine is all about. And before we even had to start talking about that, we spoke about key things like containers. We spoke about Kubernetes in Kubernetes. It goes further to teach you Google Kubernetes engine as a concept, and other deeper and deeper and deeper things you need to have an idea in order for you to be successful when you write your associate cloud exams, associate cloud engineer exams. Now this is just for the first part. The second part will be developing your applications with cloud build. And like I stated earlier for the previous course, we are going to have our lessons grouped into various sections. We have lessons. We have lessons which you are supposed to follow. We also have most of these lessons you could have slides, for example, or some of them are videos. So some of the lessons are slides, some of them are video materials which you can read, which you can go through and have a deeper understanding on what is intended or what is expected of you in order for you to succeed in your exams. And we have several labs here as well. And when you do each and every one of these labs and attempt the quizzes, you begin to accumulate experience points. And the more you continue consistently day by day, you also improve your streak. So this is very important. And I will advise you guys should go through the course. And as I stated earlier, if you have any information and if you have any questions concerning this particular topic, we are here to guide you, we are here to help you, and we are here to attend to any question and to any worries you have. Thank you so much. Thank you for your time. And um, see you guys in the next session. Bye.